Today we are going to see about linear integrator circuits. So what do you mean by an integrator circuit means? Integrator circuit is nothing but it is a miniature low cost electronic circuit consists of active and passive components that are irreparably joined together on a single crystal chip of silicon. So in electronic circuit we will see the design of the circuits by using discrete components. So in LIC we are going to see about all the components are together on a single chip called as integrated circuit, that is a IC. So advantages of IC over discrete components. First advantage, miniaturization and hence increase equipment density. Second one is cost reduction due to batch processing. Third one is increased system reliability due to elimination of solder joints. Number 4, improved functional performance as it is possible to fabricate even complex circuits for better characteristics. Number 5, matched devices. Number 6, increased operating speeds due to the absence of parasitic capacitance effect. Number 7 is reduction in power consumption. Next one is classification of IC. There are two types of IC classification. One is digital IC and another one is linear IC. So linear IC comes under analog ICs. So you can fabricate the IC based on these 7 processes. So first one is silicon wafer preparation, that is called as substrate. Either we can take P substrate or N substrate, and then step 2 is we have to form epitaxial growth, and step 3 is oxidation, step 4 is photolithography, 5 is diffusion, and 6 is ion implementation, and 7th one is isolation technique. With this we can able to fabricate an IC. Next one, basics of op amp and its symbol. So already I have told in op amp we are having two terminals, one is inverting and another one is non-inverting. So we are having one more output, that is called as output terminal. So if we are giving to the input terminal, that is inverting input, output will be 180 degree out of phase with the input. If we are giving the input to the non-inverting terminal, there won't be any phase changes. Whatever may be the input we are giving, the same is obtained at the output without any phase difference. Next one, op amp 741 pin diagram. So op amp can be represented in practical as IC 741. In that IC 741 we are having 8 pins. So pin number 1 is offset null, pin number 2 is inverting input, and pin number 3 is non-inverting input. Pin number 4 is V negative, and pin number 5 is offset null, and pin number 6 is output, and 7 will be V plus, and 8 will be no connection. So while doing the experiments either for inverting input, we go to give the input for the pin number 2, and pin number 3 is grounded. We have to make the 741 to start. So we have to give V minus as 4 volt that act as a reference, and V plus as 5 volt or 7 volt. So with that we can able to get the output as an amplifier in pin number 6. If we want to connect it if we want to get a non-inverting output, means you have to connect the input to non-inverting terminal, that is pin number 3. You can take the output at pin number 6. Next one, packages of IC are of 3 types: the metal can package, dual inline package, flat package. Next one is the diagram for metal package. Here you can see the diagram for how an IC can be packed as a metal. Next one is dual inline package. So normally we are going to use this dual inline package. So one side we are having 4 terminals, and the other side we are having 4 terminals, totally 8 inline package of IC 741. Next one is flat package. It is ceramic flat package. You can see the diagram here. Next one, power supply connections. You are going to give a negative connection to pin number 4 and a positive connections to pin number 7 in order to make the IC to turn on. So you can either give the input to 2. If we are giving the input to 2 means 3 will be grounded, and vice versa. If you are giving 3 means 2 will be grounded. You can able to get the output at pin number 6. So 15 volt is required for both V plus and V minus while you are doing the experiments. So this is the equivalent circuit of an op amp. We are having VD, different voltage, the two inputs V1, V2, and input resistance and output resistance. A0L is nothing but open loop gain, and Vout is equal to open loop gain into the difference voltage of IC op amp. Ideal characteristics of op amp. Open loop gain is AOL is equal to infinity, input impedance RA equal to infinity, output impedance R0 is equal to 0, and bandwidth PW is equal to infinity. 0 offset Vout is equal to 0 when V1 equal to V2 equal to 0. Next, we are going to act this op amp as an inverting amplifier. See, a simplified diagram is given for inverting amplifier. So the input is given to inverting input, and our non-inverting input is grounded. That is, you can see here Vi is given to the negative terminal and the positive terminal is grounded, and the current I1 is flow through the node A to the inverting input. So RF is connected as a feedback which act as a shunt to this op amp, and RL is the load resistance. You can get the output here. So the equation, if you want to calculate I1, you can see here I1 is equal to V1 by R1, and Vout is equal to I1 into RF, that is equal to minus V1 RF by R1. So total closed loop gain is equal to output by input, that is equal to minus RF by R1. So the minus indicate, or the subtraction indicates, it is inverting gain. So it represents as minus RF by R1. So VA minus V1 by R1, that is at node A we can able to apply Kirchhoff voltage law. So one voltage is VA, another one is VI. So VA minus VI at node A by R1 plus VA minus V0 by RF equal to 0. You can obtain this result minus RF by R1, output by input. So this can be explained with an example. Design an amplifier with a gain of minus 10 and input resistance equal to 10 kilo ohm. So previously we have the formula minus RF by R1. So RF is nothing but feedback resistance and R1 is 10 kilo ohm. So minus 10 will be your RF, and R1 equal to 10 kilo ohm. RF is equal to minus ACL into R1. So minus 10 into 10 kilo ohm, that is equal to 100 kilo ohm. So you can calculate the shunt capacitance as 100 kilo ohms. Thank you.